So having said that, ladies and gentlemen, let's start off. We have the complete pitch set for our two-day conference. And let's start off with the first panel discussion of the day. It will focus on, we're going to take a deep dive into the heat rate control and optimization measures, an overview of the best possible ways, strategies, and practices adapted by the Indian thermal power sector. Right from optimization of real-time combustion processes to cooling system, heat loss recovery, and cooling system optimization, fuel gas heat recovery, and a lot more is going to be discussed in this session. I would now invite our moderator for this session. Request you to please turn your video on as I take your names. Mr. Prabhat Verma, Managing Director, Runh India. Mr. Verma has over 30 years of global business operation experience with companies like ABB, Honeywell, Delta, and Doosan. He has executed multi-million US dollar projects in the power and oil and gas sectors, both in India and abroad. He holds strong relationships with business stakeholders, policymakers, government bureaucracy, PSU, and project owners. He has mentored many unicorn startups while in association with IIT Madras for fundraising and product development. He has also worked with USAID, KFW, GTZ, Zyka, J. Cole, World Bank, and many bilateral cooperation funded projects successfully. He works closely with NGOs, consultancy organizations for promoting environmental and clean energy solutions. And as a technology enthusiast, he has mentored futuristic technology solution for developing, bringing, implementing new technologies for renewable energy and clean environment. Thank you for joining us today, sir. Request you to please turn your video on. And I would also like to invite our panelists who would be joining Mr. Verma for this session. Please welcome Mr. R. Raghavan, Tata Consulting Engineers Limited Vice President, Business Head Power. Mr. Raghavan is functioning as business unit head for power business at Tata Consulting Engineers. He is a power plant engineering professional with more than 25 years of engineering and project management experience in TCE. He has executed several power projects for various customers across the globe in different roles and capacities and held many leadership roles in TCE before taking up the current role. Mr. Raghavan is a member of several technical bodies and actively contributes in various technical fora. He is also a life member of the Indian Nuclear Society and Society of Power Engineers India. Co-presenting with him will be Mr. Sourav Nayek, Process Engineer, Tata Consulting Engineers. Mr. Nayek has been working in Tata Consulting Engineers for about 15 years now as a process engineer in thermal sector. He has handled various coal-based and gas-based thermal power projects in the role of a project manager and mechanical engineer. He is now working as a team lead for the environmental sustainability, plant performance, and efficiency projects in his organization. Also, please welcome Mr. Pankaj Bhartiya, Director, Efficient Powertech Solutions, ex-NTPC consultant. Mr. Bhartiya is a director at Efficient Powertech Solutions and an independent consultant for efficiency and reliability in the power sector. With over 40 years of experience in the sector with NTPC, he has worked for 20 years in the coal-based power plant in the field of instrumentation and control design, commissioning, maintenance, renovation, and modernization. Thereafter, he has worked for 17 years in the field of efficiency and reliability at NTPC Corporate Group. He has also worked on other bilateral projects with Zyka Japan, with many SEBs for efficiency and reliability pilot projects for capacity building and technology transfer, leading to improvements in plant efficiency and reliability. He has been conducting training and implementation programs for maintenance management and RCM for the utilities and OEMs. Co-presenting with him is Mr. D K Agrawal, Director, Efficient Powertech Solutions Consultant at Jindal Power, ex-executive director at NTPC. Mr. Agrawal has over 37 years of national and international experience in various fields of power sector with TCE and NTPC. He has worked for 4 years in erection and commissioning of the first 210 megawatt unit and 9 years of setting up NTPC design and engineering wing. The experience with TCE and on-site exposure at BI UK at NTPC has helped in contributing improvement in engineering processes. He has also worked on other bilateral projects with Zyka and with many SEBs for efficiency and reliability pilot projects. And he too has been conducting training programs and facilitating and establishing maintenance management systems and efficient management systems for the utilities. We will have Mr. Raghavan along with Mr. Nayak making their presentation first, followed by Mr. Pankaj Bhartiya and then Mr. D K Agrawal. Each member will have 20 to 25 minutes and an additional 5 minutes with the moderator, Mr. Prabhat Verma, for the discussion post their presentation. But before they take over, I would request our moderator, Mr. Prabhat Verma, to give your introductory notes on the session and take the session forward. Over to you, sir. Mr. Prabhat Verma, requesting you to start your video and unmute yourself, please. Sir, you need to unmute. We are unable to hear you. And requesting the rest of the panelists to stay on mute and only unmute yourself while you speak so that we ensure complete clarity in the session.
Thank you, Shriyal, for my introduction. Good morning, my co-panelists, delegates, ladies and gentlemen. I feel honored to moderate the session, having power sector gurus like Mr. Raghavan, Mr. Bhartiya, Mr. Agrawal, Mr. Sourav Nayek. I have learned a lot from these people in my career, and this is an opportunity for me to be on panel with them. It's an absolute honor to me. They are contributing significantly to the power sector with their great knowledge and experience towards solving the problem faced by power plants operators. Heat rate issues are one of them. Heat rate improvement, according to me, it's a continuous process. I mean, it cannot be completed in one go, and it should be a passion. And it was really good to hear from Mr. Malik, Mr. Sidwal, Mr. Chakravarti about all those things happened in last 20-25 years, and we have seen a big change. We have seen the big benefit out of it, like PAT scheme. It has significantly helped power plant to be more efficient, and when power plants are more efficient, definitely there are less coal consumption, less emission, and better life of the equipment, better life of the operators. So definitely a lot has happened. It was a good first session and a good summary from all those things which has happened. And this must continue. Heat rate improvement, thermal power efficiency is the name of the game today. Power plants are stressed and facing a big challenge because there is a renewable energy which is given the first preference, and which should be, I mean, that should be the right approach also. So with each percentage of improvement in the power plant gain, the bottom line improves. That justifies the investment both for the level of performance, for better environment. Most of the plants are stressed today, needs heat rate improvement for the lowest cost of power generation and minimum emission of GHG, SOx, NOx for clean environment, better life, and better life for our future generation. I'll not take much time because I also want to hear a lot from my co-panelists. I'll not take much time, and I will invite them to start sharing their views. I think Mr. Raghavan and Mr. Nayak will be the first to present. So please go ahead and share your experience and knowledge for the betterment of all the people who are listening to you. Please go ahead, sir.
Okay, good morning, Mr. Verma. Thanks for setting the context for the first session. I'll be sharing my screen. I'm joined by my colleague, Sourav Nayek. So both of us would be making this presentation. I will share the screen. Shreyal, I'm not able to share the screen. It's showing host disabled attendee sharing the screen.
Yes, we are just giving you access. Just allow me a minute. Yes, Mr. Raghavan, you can try now.
Yeah, thanks, Shreyal.
Yes.
I have to select entire screen, right?
Share screen. You should
entire screen or
yes.
window. Okay, entire screen.
If you have the PPT open, you can directly click on the PPT.
Okay. Hope you are able to see now.
We can see your screen. You could just go to the slide show mode of the PPT.
fine now?
No, we are unable to see it in the slideshow mode.
Okay, once again. Let me share once again.
Yeah, sure.
It's okay.
No, you've changed your view mode, sir. Give me a minute.
Oh, sorry.
Go to the share, keep your PPT open first. Ensure the
Yeah,
PPT
correct.
is already open. Go to the share
Yeah.
screen mode and click on the PPT.
Yeah, share screen mode only. I'm doing that.
Okay, now at the bottom of your PPT screen, you will see the slideshow option on your right. You'll see there are 3-4 notes is there. Next to notes, there are a few other options. The last option is the slideshow option.
No, I'm not getting that.
Bottom right. I can see it on your screen. Come to the right. Come to the right.
Okay.
Yeah, below that. Where you can see the zoom plus minus just next to that.
Zoom plus.
You're on
Here?
your cursor is on the left of your screen. Come to the right
Okay.
of your screen, sir.
Okay.
Come below. Below that. Okay, yeah, the option right there that you see. Can you see there is an icon over there? A little more to your left.
No, I'm not seeing that.
Oh, you're unable to see it. Okay, but is the slide visible to all the speakers? And we could even continue this way.
Sourav, otherwise, can you share, Sourav?
Yes, please. It is visible.
Is it in the slideshow mode?
Yeah, yes.
Sourav, I would suggest you can go on sharing.
Okay.
Sorry for this slight inconvenience.
No problem.
We should have shared the PPT because we were ready with the PPT earlier. We could have.
Is Mr. Sourav sharing the screen now?
Yeah, he's sharing.
So, Mr. Raghavan, you could stop share screen first.
Yeah, I have already. I have stopped sharing. Let me try now, otherwise.
No, I'll just pass on the rights to Mr. Sourav if he's going to be sharing it.
Now I have shared. I don't know whether this works.
Oh, I've just shared the rights with Mr. Sourav now.
Okay.
Yeah.
Okay.
Mr. Sourav, can you go to the share screen option, please?
Because we are all comfortable with Teams meeting rather than Zoom.
Yes.
Yeah. Sorry.
At the bottom of your screen, you'll see a green color icon which says share screen.
Sourav, are you able to do that? Sourav?
Sir, can you share the latest files?
No, you go ahead with that.
Okay. Yeah.
Shell, otherwise, can you give the rights to me once again?
I can do that. Yes.
Yeah, let me try.
Yes, I've given it to you.
Share screen. I'm not sure now whether it works.
Yes, it works. You're on the
Clear.
slideshow.
Yeah, very well.
It's there in slideshow?
Yes,
Yes,
it is.
Yes.
perfect.
Okay, okay. Yeah, good morning once again. Sorry for the slight inconvenience. We are going to present on the heat rate improvement in thermal power plant from a consultant perspective. I'm sure there are many speakers from utilities, many speakers from probably manufacturers who would talk about from different perspective, from the operation, design perspective, design of boilers and turbines perspective. So our presentation would be mainly from a consultant viewpoint. I'm joined by my colleague Sourav Nayek, and he has extensively worked in thermal power projects. So what we are going to cover in this 20-25 minutes presentation, a brief overview of TCE. Many of you would be knowing about Tata Consulting Engineers. I would not take much time. It's only 2 to 3 minutes to set the context. And the Indian power sector, which is predominantly coal-based as of now, in spite of the energy transition initiatives taken by the government, coal will continue to play a major role for at least few decades. So definitely heat rate improvement is a subject of great importance, because whatever the utilities we are having, the coal-based power plants we are having in India, definitely we have to operate at the maximum efficiency to have better benefits and the lower emission, lower CO2 emission. Though the other energy transition initiatives would continue in terms of renewable, nuclear, and hydro, but definitely we have to optimize the performance of the existing coal-based power stations. Then few quick definitions and the benchmark values for heat rate for various capacities, and what are the why we have to improve the heat rate, what benefit we are going to improve at the plant level, either financial or from a technical perspective, what are the measures, why we are taking these for heat rate improvement, and some of the broad level parameters which are affecting the heat rate. That is very important. Unless we know how the heat rate is getting impacted based on the various operating parameters, so that we will be able to take action to improve the performance of the various equipment and achieve the better heat rate. And flexible operation, as the previous speakers also mentioned, because this is going to be the order of the day for thermal power plant, as more and more renewables are getting integrated into the grid, which are in operation, because all renewables have the must-run status. So obviously the coal and gas-based power plant should have the flexible operation to meet the demand. So these are the brief agenda. TCE, we started our operations in 1962. We are a 60 years old company. In fact, TCE started with power project. That was our first project was country's first 150 megawatt. We started in 1960 and we commissioned in 1964. So TCE is proud to have been associated with many first of its kind projects in India across various industry domains, and of course in power sector. We are in power sector engineering for last 60 years. So country's first 150 megawatt, country's first 210 megawatt, country's first 500 megawatt, and of course country's first 800 megawatt, the Mundra ultra mega supercritical plant. So all first of its kind project in terms of higher capacity units have been engineered by TCE. To date, we have done more than 11,000 projects across globe in various industry domains. We have 5,000 plus engineers, and out of that 800 to 850 engineers are working exclusively for various power projects. Till date, in the last 60 years, we have delivered 200 gigawatt of power projects globally, predominantly in India. I would say if you take the Indian power sector, 30 to 35% of Indian power sector plans have been engineered by TCE over the last 60 years. So this is brief about TCE. If you see the capability, we have a full range capability right from the concept development, we call pre-feasibility and feasibility report, because every power project would start with preparation of feasibility report and DPR and environmental impact assessment studies, detail engineering, owners engineering, and right from project management, various procurement activities, supporting all the stakeholders, because we have executed projects supporting various executors, be it a project developer or project owner or EPC companies, equipment suppliers like BHEL, Siemens, GE, as well as the financial institutions or lenders. So we have worked with all the stakeholders of the project, and we have the full scale capability right from the concept development to commissioning and beyond. So coming to power business more specifically, as I mentioned earlier, we are in this business for last 60 years, capable of delivering full range of services from concept to commissioning. We have 4 major sectors. We have executed projects of different generating types, I would say. Nuclear, we have done PHW, pressurized heavy water reactor, FBR, green power, hydro, solar, wind to the tune of 45 gigawatt. Since thermal is the topic of importance, I would say we have executed projects of different types, coal-based, gas-based, captive and cogen of various capacities. We have done plant as small as 5 megawatt to the as high as a single unit of 1000 megawatt. We have done a couple of 1000 megawatts for international customers. And of course, in India, we have the largest capacity of 800 megawatt, which we have done for Mundra and several other customers, Tata Power and several other customers. And we have a separate division, transmission and distribution, having full capability for substation engineering, transmission line distribution system. And we are working in the emerging areas like digital services. Previous speakers talked about importance of digital solutions. And one of my colleagues would also present the various digital solutions we have for thermal power plants, and more specifically, how we can improve the heat rate. That is in the today afternoon, one of my colleagues is going to present on the digital solutions. So why we are talking about, if you see the heat rate improvement is very important topic, is relevant today, and it will continue to be relevant for a few decades, I would say. Currently, we have in India 400 plus gigawatt of installed capacity. Out of that, 210, almost half of the installed capacity is coal-based power plant. So it is very important that we operate this coal-based power plant in the most efficient manner so that we get advantage in terms of emission, in terms of performance improvement, and all the other financial benefits. So what is going to be the plan? It's the data published by CEA. So obviously, coal will continue to be the major share, holding the major share in our generation mix even by 2030. Though government has announced the net zero by 2070, so gradually the coal-based power plant will be retired, and equivalent capacity in terms of hydro and nuclear and renewable would be put into the system. So if we talk about 2030, coal will still have 30+% of share, even if the installed capacity going to 800 plus gigawatt, almost double from the current levels, but still coal will have 250, 260 gigawatt. So it is very relevant topic for the next, at least for 2 to 3 decades. So that I want to leave this message to the audience here, why we are talking, because many would think that we are focusing on renewable energy, solar, wind, and hydro. What is the relevance of talking about improvement of performance of the coal-based plant? Because it is going to continue and it is important. So we talk about heat rate. So we thought we will spend a couple of minutes to give the definition of various heat rates. Okay. So if you see, there are 6 things are given. I would ask the first and 2, first and the second one, which should be it should be looked at in pairs. I would say the first one and the second one, if you see the turbine cycle heat rate, we talk only about the performance of the turbine and the associated turbine cycle equipment. So total heat input to the turbine cycle by the electric power output we call turbine cycle. Here we are excluding the boiler efficiency. The next one is the unit heat rate. So here we are taking into the boiler efficiency, that the boiler also included total heat input to the cycle or to the boiler divided by the gross power output. So because sometimes it people take turbine cycle heat rate by mistake for unit heat rate. So it is important to know the difference. Excluding the boiler is the turbine cycle heat rate. If we include the boiler efficiency, it is the unit heat rate. Then another definition, another way of defining is net heat rate versus gross heat rate. What is the difference? Here, If you want the net heat rate, we have to take the net electric power excluding the auxiliary power. And if you are talking about the gross heat rate, we should take the gross electric power at the generator terminal. So that is the gross heat rate. Another way is design heat rate versus actual heat rate. Design heat rate is the one which is guaranteed by the supplier manufacturer based on the design conditions and certain design parameters. And actual heat rate is the actual the amount of fuel that is burnt in the boiler and the total power generation in actual operating cases. So these are the various definition of heat rates. Predominantly, we can talk about turbine cycle and unit heat rate at the gross level. So that is the more prevalent definition. If you see the evolution of thermal power sector in India, I talked about 150 megawatts started in 1960s. Before that, we started implementing a smaller capacity units, 50 megawatt, 67 megawatt also is one of the standard size we had earlier. So from 50, we gradually increased the unit rating to higher capacities. Mainly, we got the heat rate improvement by that increased unit rating also. When we go for increased unit rating, we obviously increase the steam parameters, both pressure and temperature. So these are the guidance values published by CEA for various unit ratings. What is the turbine cycle heat rate at the design condition, 100% TGMCR. That means 100% power output by the turbine at the generator terminal and 0% makeup. These are all the guidance values, and as a consultant, we used to specify that the suppliers should give at least match these or provide better than these defined heat rates. So that is the expectation. So this gives a broad guidance value for the turbine cycle heat rate for various capacities. And in case of 500 megawatt and above, we have two options. It can be motor-driven boiler feed water pump or turbine-driven feed water pump. Accordingly, the heat rates values are defined for reference. So when we talk about when the manufacturers or designers specify and give at the time of supplying the equipment, they guarantee certain heat rate, both turbine cycle and in case of boiler, the boiler efficiency is guaranteed by the supplier. So we arrive at the unit heat rate. So that is the design case. But over a period of time, you can see the deterioration of the heat rate due to various reasons. So this can happen due to accountable losses or unaccountable losses. So what are the accountable losses? There are deviations in the critical parameters from design. For example, if we design the boiler with certain pressure and temperature, and if you are not operating the boiler at the pressure and temperature or cooling water temperature variation. So we designed the entire power plant and associated system for certain design parameters. And if you are not operating the plant at that specified values or design values, then we will not be able to achieve the original guaranteed heat rate. That is one. Deterioration in equipment performance, boiler, turbine, or any rotating equipment. So because of the continuous operation of that equipment and systems, there will be deterioration in the equipment performance, but it can be accounted because there are various curves available. We can verify, we can check over a period of time how for example, how the turbine would degrade. So there is a degradation versus degradation factor versus the number of operating hours. Okay, so then the fuel characteristics also important. Though we designed the boiler for certain specified fuel qualities, characteristics, but in actual, we will be burning different types of fuel because of the availability and also based on the cost of fuel. So based on the difference in fuel characteristics, the boiler efficiency would be different. Accordingly, the heat rate would be different. Auxiliary power consumption, because we would be operating some of the standby equipment or the degradation of those pumps or fans or compressors can also cause higher auxiliary power consumption during the operating period. Operation practice of the plant, how we are operating, maintaining the various systems and equipment will also have. So these are all the categories which come under the accountable losses. And we have several factors which we cannot measure, we cannot account, because passing of walls and steam traps, passing of high energy drains, for example, heated drains going into condenser, is a typical thing. We will lose heat rate because of that. And where equipment assessment is very difficult, and of course, radiation loss, natural and forced convective loss, and uncertainties in the instrument. So these are all unaccountable losses. So this the difference between the actual and design, the accountable and unaccountable losses contribute to the difference in actual and design. We are very clear that we need to operate the plant at the specified or guaranteed heat rate. So what are the benefits we are going to get if we have the better heat rate closer to the design or guaranteed heat rate? The first one is a reduction in the plant operating cost, because if you operate at the better heat rate thing, you will be using less coal because of the higher efficiency. So definitely it will have reduction in the plant operating cost. And the third point is also related, increase in the operating margin. And the second one, because of the better heat rate and lower coal consumption, there will be reduction in emission of greenhouse gases and other pollutants, and reduction in erosion and lower breakdown. So obviously, the better heat rate is going to have several benefits to the plant operators. And to give just an example, or the importance of this heat rate, even every 1 kilocalorie per kilowatt hour improvement for unit size of 600 megawatts subcritical, considering this specified coal GCV and PLF. So 1 kilowatt improvement will have an annual coal saving of 1,240 tons, which means that there will be a CO2 reduction to the tune of 1,700 tons per annum. So you can see, we may think that 1 kilowatt is a too small a value, but if you do for a plant of 600 megawatt, the annual coal saving is to that extent, 1,200 plus tons. So definitely it will have a savings in the operating cost and better operating margin, and also emission is lower. So this is one typical example. We can do similar things for various capacities. So obviously the heat rate improvement is going to have better benefits to the plant operators. So what are the various heat rate improvement measures we have? So there are 6 or 7 we wanted to talk about in this forum briefly. So I would take the first 3, and I would request my colleague to talk about the balance. The first one is the boiler efficiency improvement. This is very obvious that because the plant heat rate is directly linked to or having with the boiler efficiency. If you have the boiler efficiency better, that is equal to the design value, obviously the plant heat rate would be better. So what are the various attributes or factors affecting the boiler efficiency? One is the dry flue gas loss. Second one is the excess air deviation, excess air due to the RAPH leakage, air preheater leakage. There are combustible loss in the bottom ash and fly ash, because there will be unburned carbon that will be going along with the ash, that will have the lower boiler efficiency. Heat loss due to moisture, and also hydrogen in fuel, because hydrogen is obviously converted into H2O, so that also will consume the latent heat of evaporation. Because of that, the boiler efficiency would be low. Heat loss due to band insulation and accounted losses. So we know what are the factors that would affect the boiler efficiency. So if you take care of that, obviously the boiler efficiency would be better, equal to their design value, and we will have a better plant heat rate. So how we will be able to achieve that? Maintain the higher mill outlet temperature, reduction in excess CO2, smart suit blowing. Actually, suit blowing also is very important. Otherwise, the surfaces will not have proper heat transfer, which will affect the complete heat pickup by the various pressure parts, and it will affect the back-end temperature, that is the dry flue gas loss will have a direct impact due to this. And air preheater, checking and cleaning of air preheater baskets, optimum number of mill operation during minimum load. This is also very important. Ensuring proper sealing to protect the air leakages, maintaining the proper fineness in pulverized coal. So if we take care of these measures during operation, obviously we will have better boiler efficiency. And to give an example, 10% raise in excess air will have 0.5% increase in loss. 10% raise in flue gas temperature will have 0.5% increase in loss. And obviously the unburned carbon in actually the ash will also have lower boiler efficiency. Of course, increase in the moisture content also will have increase in the loss. So one parameter is boiler efficiency, and we have to operate the boiler at the highest possible efficiency at any point of time, given the variables, because we will not be having the design goal always. And because of the deterioration, there will be over a period of time degradation of various systems. There will be some impact in the boiler efficiency. But the point here is, if you want to get a better plant heat rate, you have to operate the boiler as efficiently as possible and taking care of some of the improvement measures specified here. The second one is talked about, I think in the initial discussion also, the speaker mentioned about the spray water or the temperature water, both in case of superheater and reheater. So this also is having direct relevance or impact on the heat rate. So why we are the superheater reheater spray water quantity is increasing because of fouling of boiler water walls and superheater surfaces, improperly adjusted set point, leakage in the spray water control valves, higher levels of excess air. So these are the various causes due to which the temperature quantity would increase. Obviously, there are corrective measures that should be taken during the operation, proper wood blowing, burner tilting mechanism. If we are having the tangential firing system, obviously the burners would have a tilting mechanism, and proper burner tilting will have less spray water both in the superheater circuit and the reheater circuit. Calibrate the temperature control, repair the spray water wall so that we can avoid the passing of spray control wall and reduce the excess air to proper level. Always we should operate the boiler at as close to the excess air specified, because any amount of additional excess air will increase the flue gas quantity, which in turn increase the dry flue gas loss, and due to which the boiler efficiency will drop. So to give a perspective, what will happen for every 10 tons of spray water quantity increase, so the impact on the heat rate, obviously the superheater will not have so much, but even 1 kilojoule per kilowatt hour, 1.2 kilojoule per kilowatt hour is the impact for a typical 800 megawatt power plant. And in case of reheater circuit, the impact is huge, 10 kilojoule per kilowatt hour for every 10 tons per hour improvement in the increase in the spray water quantity. So obviously we should make all measures to be taken to ensure that we have optimum or as minimum spray water as possible, both for superheater and reheater. The third one is the turbine efficiency. Of course, this is very important. Turbine cycle heat rate is having direct impact on the heat rate. For example, 1% decrease in turbine efficiency at a HPI, PLP combined, it will have about 20 kilojoule per kilowatt hour impact. So this is also huge value, and we have to see how we can minimize how we can improve the turbine efficiency or minimize the losses, interstate sealing, replacement of gland packing, repair or replace the turbine blades wherever heavy erosion has taken place. Obviously, we have to replace, probably not the initial stage of the operation, but after a few years, if required, we have to take care of the erosion, particularly a few blades to be replaced. That should be done, and repair the nozzle block if required. So if we take care of these and maintain the turbine efficiency as high as possible, then we will be able to derive the better turbine cycle heat rate. So I talked about the parameters: one, boiler efficiency, improving the boiler efficiency, reducing the superheater reheater spray or attenuation quantity. Third one is having the optimum or maximizing the turbine efficiency to have the better heat rate. Now I would request my colleague to talk about the balance 3 points, and as well as he would talk about the flexible operation of thermal power plant, which is very important in the present day context. Sourav, can you please take this up?
Yeah, Thanks, CE, and thanks, sir, for your insight on this important aspect. I will take you through other parameters which impacts the overall plant hit rate and efficiency. I will first talk about the condenser back pressure, which has a large impact on the plant hit rate, because as the back pressure increases, we will see a large increase in the hit rate, and that will contribute the lower turbine output and this will have a overall life cycle cost increase of the plant. So we will talk about what are the attributes of the condenser back pressure increase. These are mainly the points which we will talk about. Higher CW inlet temperature if the cooling tower performance is deteriorated and cooling water inlet temperature is increased. This will increase the condenser back pressure and ultimately the turbine work will get reduced. Insufficient CW flow because of the malfunctioning of the CW pump or the improper condition of the CW pump will also increase the insufficient CW flow and which will increase the temperature rise in the condenser. If we all know that in the condenser, it is very essential to maintain the vacuum and there should not be any ingress of the air. Proper sealing is very important. So in case there is any aspect of air ingress or vacuum system malfunction happens, then this will also increase the condenser back pressure and in turn this will increase the turbine cycle hit rate. The scaling and fouling in the condenser will also affect on the heat transfer surfaces and it will create a resistance in the heat exchange and that will also the increase in back pressure of the condenser. And the last one is we know that all from the top HP heater, low pressure heater, the drains used to come to condenser and it all will be coming based on a automated control loops. Now, if the passing of the high energy drains used to happen more from the line drains or from the any other drains which is not contributing on the overall cycle, then the condenser heat load will also increase and this will increase in the condenser back pressure. Now, what are the measures for maintaining the condenser back pressure, which is a very key aspect? One, cleaning of the tubes at part load or during shutdown period. We have to clean the condenser tube so that the scaling and fouling effect is very nominal and it is within the acceptable limit. The air ingress point monitoring of the airflow is very important so that the proper sealing is already established and we can see that vacuum pooling is within our acceptable desired value. The CT performance is another one aspect is very important and we should regularly clean the CT fields to improve the performance of the cooling tower and this will give the CW cooling water inlet temperature as a design value. Second, the CW pump health monitoring is also very important and we should periodically check the performance of the CW pump so that we get the sufficient CW flow mass storage we get from this which is required for the condenser performance. Condenser online tube cleaning system is another aspect which will give a preventive measure when the water quality is slightly deteriorated. It will give the cleaning mechanism and it will it will facilitate the condenser surface smoothness and the heat exchange through the condenser. And last, all the closed energy drains should be passed efficiently, so that the excess high energy drains are not coming into the condenser and not increasing the heat load. Here we have tried to assess for increasing the condenser vacuum, how is the impact on the turbine cycle heat rate. Typically we have done for a 800 megawatt unit. If we see the base case for 100 millibar, the TG cycle heat rate is coming 1790. As it increases from 100 to 105, the TG cycle hit rate is also increasing from 1790 to 1795, then subsequently for 110, 1800. So in this sequence, as the condenser pressure is increasing, TG cycle hit rate is also increasing.
Mr. Nayak, sorry to interrupt you, but Mr. Raghavan,
how much time we have, Mr. Verma and Shreyal?
We have another 10 minutes, but what I would request is when one of you is speaking, the other one can go on mute because there is slight disturbance coming else in the background.
Sorry.
Yeah. Next point is feed water heater performance improvement and makeup water, maintaining the proper percentage of the makeup water quantity, so that there is no much deviation from the design value. Feed water heater, the configuration, number of feed water heater giving the regenerative effect into the TG cycle is very important. And when we are selecting the feed water heater, the TTD and DCS selection is also important, which will give a significant factor for improving our heat rate. As we can lower the TTD and DCA, the heat rate will be improved. Now, after selection of the feed water and the configuration and the design parameters, there will be in the ongoing plant, there will be multiple factors which will affect the feed water performance, like changes in heater level, the extraction line pressure drop to heaters, the reduced condensate flow, then baffle leaks, heater tube fouling. These are the key aspects which impacts the feed water heater performance. Now, as a corrective actions, we should always take our control loop in a very efficient manner, so that we can maintain the feed water heater level. Our vent valves and orifice can be optimized so that we minimize our losses. The baffle leaks should be repaired periodically, and the tube bundles also to be cleaned during annual shutdown period, or whenever it is needed. We can bypass and we can do the cleaning of these tube bundles. The makeup water deviation is also another factor which will take the heater, which will take the heat rate in a deterioration. The aspect of the makeup water deviation is boiler tube leaks, deaerator venting to atmosphere, excess continuous blowdown from the boiler drum, the excess steam loss through condenser venting, valve packing leaks, and different pump seal leaks also will cause for excess makeup in the cycle. Because as the makeup quantity, as the losses will increase or blowdown will increase, the makeup quantity has to be increased to maintain the cycle overall mass flow. So this, when we increase the mass flow of the makeup water, this will increase the heat rate of the cycle. Now, what are the corrective actions? We should always look into the boiler and optimum operation, so that the boiler tube leaks is minimized. The deaerator vent orifice and the deaerator vent losses are minimized. The valve and pump leakages are also to the minimum level, and other continuous blowdown also has to be minimum, so that our makeup quantity is minimized to improve the heat rate. If we see the for feed water heater, from the top feed water heater to lower feed water heater, almost 2 to 3.5 kilojoule per kilowatt hour impact is there on the heat rate. Similarly, for the makeup water, 25.4 kilojoule per kilowatt hour per percentage increase in the makeup water quantity, the heat rate factor will be affected. The auxiliary power also is another aspect which is affected with the affecting the heat rate. One is the continuous running of the non-continuous loads, decline in efficiency of operating equipment, operation of additional equipment during low load operation. So these are the key factors for deviation. What are the corrective actions? If during the operation, if we stop the non-continuous loads, if we replace the inefficient equipment or make the repairing of the inefficient equipment, when this we are running the plant with a minimum load, then we should always use the VFD, or we should operate with a single stream operation, so that we can minimize the loss at part load. Auxiliary power also has a large impact on the heat rate, and with these corrective actions we can improve the heat rate of the cycle. The performance deterioration, as earlier speakers also mentioned, that the performance of the every equipment is very important to maintain the desired heat rate level. If there is any fouling, if there is any scaling happens in the equipment, this will make additional resistance and it will not give the desired performance. Like in turbine, if there is a salt or silica deposition in the turbine blades, this will affect the heat rate. These clearances in the flow path, gland leakages in the HP, LP or IP turbines, leakages in the valves, condenser tube scaling, this all impacts the performance of the plant. Now, what are the corrective actions? Turbine blades, we should do alumina blasting. With alumina blasting, we will be definitely maintain the turbine blade smoothness. We can avoid the roughness of the blade and we can improve the efficiency of the turbine. The gland leaks and interstate seal also should be repaired. We should maintain the seal strip leakages also to a minimum level, and condenser also should be cleaned by the different cleaning methodology. We should clean the condenser so that our overall performance is maintained. We have captured what are the different parameters, how it impacts the heat rate, like a turbine, condenser, different boiler parameters. If we see the turbine efficiency for 1% deterioration, it impacts almost 15 to 20 kilojoule per kilowatt hour impact happens. Similarly, this excess air will have large impact, 31 kilojoule per kilowatt hour. Superheater and reheater attemperation, already spoke that this also has an impact on the heat rate. The other boiler parameters, unburnt carbon, moisture in the coal, this excess flue gas temperature increase, all impacts on the heat rate. There is another significant contribution by the condenser back pressure, which is impacts a lot in the plant heat rate, and another is auxiliary power and makeup water, which we have talked earlier, the reasons and the corrective absence for this heat rate improvement. Now we will talk about the flexing of the thermal power plant. Till now we have talked the different reasons for heat rate deterioration and what are the corrective actions in an ongoing thermal power plant. Now today's need is to operate as the renewable energy sources are increasing, the power from the RE sources are share is increasing, and coal-based generation is reducing. The main aspect of the thermal power plant is to operate with a flexible operation to a minimum load. Now, what is the flexible operation of the thermal power plant? We have captured in this diagram. This is the flexible operation of the power plant is the reduction of the generation according to the demand to maintain the RE source and the thermal power source in a balanced way. And this thermal power plant has to be taken into the minimum load. The minimum load is the lowest possible net load of a generating unit, which can give the stable operating condition. Now, startup time also we have defined. The startup time is defined as the period from starting plant operation till reaching the minimum load. If we see in the diagram that the green color is the first starting point, and then with the specified time we are reaching to the normal load. So this is called the total startup time from the zero level to the reaching to the normal load of the thermal power station. Now, the ramp rate, which will be ramp up or ramp down, will be we define with respect to the megawatt per minute, and this is also in a reversible way. Either we can ramp up or we can ramp down according to the demand of from that plant. Now, minimum thermal load is the actual minimum load of the prime mover of a thermal power station, and the rated capacity. The ratio of these two is called as a minimum thermal load. Now, the flexible operation, as we seen that in 2022, as of now, we have 211 gigawatt coal-fired plant, and out of that, we are also having around 110 RE power 110 gigawatt RE power also we have already installed in the country. Now, RE power is having a major share nowadays to maintain the overall demand of the country. And here now the essence is that coal-fired power generation unit will serve as a base load unit, but it will be given as a minimum. It will have the flexibility to go to the minimum level, and RE power always will be given as the major priority, so that our net zero ambition is fulfilled. What is the impact of the flexible operation? For the flexible operation of the thermal power plant, it will have a large impact on the plant life because of the different thermal and creep fatigue of the equipment. There will be some corrosion fatigue due to the cycle chemistry. There is increase in the heat rate will happen, and auxiliary power consumption also will be increased. There will be some tangible operation and maintenance cost, and it will also call for some future expenditure. The oil consumption in the part load condition also will be increased due to frequent start-stop. If we see the diagram, we have captured how for a different rating of the unit, 210 megawatt, 500 megawatt, 600 megawatt, 800 megawatt, even at the CCGT level, combined cycle power plant, how it impacts the because of the minimum load, the loading condition, how it increases the heat rate. There is a variation comes almost 20 to 25% increases in the coal power plant, and this will further go in combined cycle power plant. Now, what are the strategies for our heat rate improvement during flexible operation? We should operate the turbine with the minimum half throttling losses. we should reduce the auxiliary power consumption at minimum load, either by single stream operation, or we should include VFD. The payback has to be checked for inclusion of the VFD, so that we get the benefit out of the operating cost. The HP and LP bypass should be periodically operated so that faster load rejection happens. The CNI system, the control loops also has to be optimized. The sliding pressure operation, damage tracking mechanism has to be established in the plant. The key essential for flexible operation, what are the steps we should take? First, we should study and analyze the plant condition for flexible operation, whether there is any limitation, whether there is any bottlenecks in the plant, we should identify. Then we should assess the influence of low load operation and how the temperature and pressure gradients will impact on the main components. In the boiler, in the turbine, in the pressure parts, in the turbine components, how it impacts the different temperature and pressure gradients during low load operation, that we need to make an evaluation. We should do the test runs of the plant performance with respect to startup, normal load and cyclic operation, and we should see that what are the constraints are there and how we can make the mitigation plans out of this. We should optimize the control systems with there are several protection interlocks will be also be there while minimum load operation. So this with respect to the coal supply, with respect to the airflow, with respect to the steam pressure, the entire control loops has to be largely automized, and there will be all protection interlocks has to be there, so that this minimum load condition we maintain a proper operation of the thermal power plant. There should be some O&M procedures also has to be optimized, considering the steam water quality, layer procedures, and the condition monitoring of the equipment. The performance optimization during part load and cyclic operation also should be looked into, because our main objective is that during flexible operation we must improve our heat rate. It should not be too much deviation should not be there, as we shown in the last slide. It is almost varying 20 to 25% in the thermal power plant. This we should minimize, and we should take the measures for this. Now, approach towards the combined cycle power plant and the process plant. There are several objectives are there for the CCPP. One is system reliability, uninterrupted power and steam, reduction in heat loss and specific energy consumption, lower power and steam cost and reduce production cost, environmental compliance to statutory norms. Now, how we achieve the specific energy consumption in a process plant, that we have made the diagram. Our approach should be that how much total thermal energy input we are giving, out of that which is we can use and which are irrecoverable losses are there. Out of this heat energy available for use, we have to see what the being recovered and what are the other opportunity that we can explore. The opportunity to be explored also, we have multiple things, as earlier speaker also mentioned that the daily management through equipment performance improvement, we can make a lot of improvement in the specific energy consumption. Another aspect is that we should explore for the new technologies to recover the heat losses and to reduce the specific energy consumption in the plant. There are some heat losses technology will be available, but with a very higher cost. That viability we need to check. Ultimately, our objective is to reduce the specific energy consumption with these steps in the process plant, and it should be with a benchmark value in the entire globe. So this is what we talked about, the heat rate improvement in the thermal power plant. With this,
Hello. Hello.
Yeah.
Yeah,
Yes,
Mr. Verma, we concluded our presentations. Sorry, probably we have taken a few more minutes extra. Sorry, we have concluded the presentation.
It was really very informative and, great amount of information you shared. Shriyal, we will have question answer now or we will have it later on?
Actually, I think we can move on to the next presentation. And in the meanwhile, I would tell all the attendees that you'll see a Q&A box at the bottom of your screen. So please
That would be
start
great.
keying in your questions over there so that we can take it at the end of both presentations. Would that be okay, Mr. Verma?
I mean, we need to memorize, all. It's a very, heavyweight subject, the heat rate.
So
It
what
is
we
always.
could do is, if you have any questions as a moderator from your end, you could start with that. And in the meanwhile, if the attendees put any questions in the Q&A
All
box,
right.
we could take that up.
All right. So
Yeah.
I will ask some, one or two questions, Mr. Raghavan and Mr. Sourav, it was a great presentation.
Sorry, Mr.
You,
Verma, can I request you to put your video on, please?
oh, yeah, sorry.
Yes. Thank you.
Yeah, okay. Yeah. All right. So, Mr. Raghavan and Mr. Sourav, you made a great presentation, which is always there from the world of Tatas. You are uniquely positioned to give consultancy, to develop software, to run the power plant. And probably you are one of the organization you can demonstrate. I was expecting a use case, at the end of your presentation, because whatever you talked about, it is all, a laundry list, wishful thinking. Because when we say it should be run efficient, if something inefficient, and my personal feeling is the human intelligence somehow is not as dependable as artificial intelligence. So my first question is, when can we see the first power plant, coal-based power plant, which is fully autonomous, without much intervention of human being? For two reasons. You have seen a lot of accident happening in the past in the power plants. A lot of lives have gone, and we know that in every power plant there is a huge entry of manpower every day. I have seen in the coal belt thousands and thousands of people getting into the power plant and working and coming out. So my first question to both of you: when can we see the first power plant fully automated, fully autonomous, fully digitalized in a control mode? Because within Tata, you have everything. You have TCS, you have Tata Power, you have TC. This is my first question. You answer, and then I will ask the second question.
Yeah, Mr. Verma, this is right. I agree. Coal plants have a lot of operators compared to the gas-based power plant or other forms of power plant. But only thing is, if you ask me, technically it is possible, but at the same time, we have to see the cost involved, right? Because if you see, there are some systems we want completely automated, some system we want semi-automated, some system the general design philosophy used to have manual intervention. So technically it is possible to have 100% digitalized autonomous plant, but in practical, considering the cost consideration and due to several other things, it is not being practiced. It is not from the absence of technology, or it is not from the point of view of we are not able to do. We means all the stakeholders, but it is from the cost perspective. But there are plants in combined cycle plants in India and elsewhere in other parts of the world, which are fully with a single start button. You can start the plant and go to the 100% load. Okay, that is the first point. And you talked about the use case. I definitely we could have included, but at the same time, there are not only in within our group, there are many utilities. They have implemented several heat rate improvement measures in the plant. There are many use cases are there. So what we thought is the first presentation to define the fundamentals and what are the things we need to do. Definitely the utilities we are going to present can have some of the use cases. And one of my colleagues, as I mentioned earlier, is going to talk about the digital solutions, which is coming in the second half of today's presentation. He would specifically talk about some of the digital solutions we have developed exclusively for power plants. So this is my short answer to your question. Hope this clarifies your thing. And moreover, I would say, Mr. Verma, now the point is how efficiently we can run rather than introducing a huge capex investment in terms of digital. I agree. There are some parts, some portion of the plant operating thing we should implement digital so that we will be able to manage and operate the plant better, maintain better. But at the same time, we are in a thing we don't want to spend too much capex investment for many of the running plants which are 15-20 years old. That is also a point, because we have been discussing with many developers. We have some design digital solutions, but the point is they are very hesitant to implement at a large scale digital solutions in the plant.
Thank you, sir. Thanks for your explanation. And we hope that things will further improve and the time will come when we will have not much limitation of the capital, and we will have, because coal-fired, as rightly discussed, the world has failed to come to an agreement to stop burning fossil fuel. So coal is going to continue. This is the takeaway from the COP27. So coal is going to continue, but coal thermal power plants, I mean, it should be a like 5-star hotel, because it should be free from all kind of dirtiness and the stigma attached to it. So this is the time to work on it. Thank you so much, Mr. Raghavan.
Yeah, only one more point I would like to add. Coal will continue. Even I was having discussion with the Niti Aayog officials a few days back. Even in 2070, the coal will have 10 to 15% share. Only thing is, at that time we may have to have carbon capture and that type of systems so that we will be able to achieve net zero. The projections are even at 2070, there will be 10% of generation coming from coal-based power plant. So because we cannot completely avoid, because we cannot have so much ramping up of nuclear hydro to have a base load case. Renewable, of course, we can maximize the use of renewable, but those are all intermittent power generation during the day, for the solar power generation, and seasonal because of the wind power generation. So as you have rightly pointed out, coal will continue even at 2070, but the other technologies would come. Carbon capture, the coal plants, high efficiency ultra supercritical plant with carbon capture would be the solution to have net zero targets at that point of time.
Raghavan sir, when we will have all those technologies getting developed with the consultants like you? I mean, for carbon capture, again, I know one project of Tata is still there. Again, we are dependent on someone else. So when we will have all those indigenously available, because our problem is we always look towards westward, right? I think a lot of development can happen in this country. And on coal-fired power plant, I have seen the R&D has happened the minimum. We have been very, very stereotyped. Even Sourav talked about VFD. And whenever we talk about VFD, we always talk about payback. VFD should be the part of original specification of the tender itself. Why for VFD? We always talk about payback.
I agree, sir. I agree.
Talking about high-level digitalization, just 1 minute. Mr. Sidwal talked about big data, artificial intelligence, all very high, level jargons on digitalization, and we are having all the same old manpower who are running this power plant. So they need to be trained, number one. And number one, consultant like you should put as much as digital as possible in the specification so that users are compelled to use it, because cost and capital is the issue with the end user, not with the consultant.
Yes, sir. So just I'll take only 1 more minute. Now, if you see the recent specifications, there are few projects we are doing coal-based plant. Even now we are doing. So few projects, if you see the recent one, we are introducing the additional sensors so that the digital thing can be implemented. And one more point I would like to add, Government of India, BHEL, NTPC and IGCAR, 3 institutions have developed advanced ultra supercritical technology. Ultra supercritical technology is already existing, This is advanced ultra supercritical technology with 700 plus 700 degree and 310 bar. The technology is now available for commercialization. We had discussion with, again, Niti Aayog, NTPC, BHEL has developed both boiler and turbine with advanced ultra supercritical technology, completely indigenously developed technology. So they have not taken anything from external world, and now government is also keen to implement this advanced ultra supercritical technology, which is having that 310 bar pressure and 710 degree superheater reheater temperature, which will have 4% improvement in efficiency compared to ultra supercritical unit. So it is coming almost close to 48% plant efficiency, which will have huge impact. Government is pursuing that. That also we had a discussion because they first wanted our opinion, our discussion. We had discussion with Niti Aayog, BHEL, and other IGCAR, instrumental in developing the new materials to withstand that such a high temperature. So we had the discussion. So I agree that in the early stages, we depended on Western technology, but now we have the capability to implement advanced supercritical technology. Such designs are not available elsewhere. So that is the point I would like to make. But your point is noted because we depended on external thing. Even in the carbon capture, we are depending on international technologies. And some of the companies are now making an effort to do indigenous technology.
Thank you, sir. I respect your optimistic view about ultra supercritical technology. We are also hearing as a power professional for many years. I wish it comes true and we see it running somewhere. My second question, like Sourav talked about flexibilization. And I know the great power plant operators, Mr. Bhartiya is here, Mr. Agrawal is here, they will talk more about it. I think plants are being run in a flexible mode. But then there are limitations. Beyond a certain technical minimum, maintaining the flame is difficult without the oil support. So my question is, and we hear a lot about plasma ignition and all those. My question to you, your experience as a consultant, how about replacing the oil ignition system with the plasma ignition? And do you think it is going to be beneficial for flexing the power plants?
Sourav, you'll be able to take this up.
Yeah. No, this oil firing during low load operation is now the this necessity, sir. But lot of the developments are going on for the plasma ignition. Now we also are exploring to replace the oil firing during low load with this plasma ignition. But yes, of course, this is not very in a mature stage. We will definitely get more information. Our team is also exploring this thing, and maybe in due course, a lot of some pilots also will be making. So with that, we will get some information, and we will share our experience to the forum going forward, sir.
So presently, you have no experience of using plasma ignition technology.
No, right now,
no, we don't have that experience.
All right, Shriyal, I think my questions are done.
Yes, and Mr. Verma, we have like a few questions in the Q&A box as well. Would you want to take that up? There are about 4 questions there.
Oh yeah, I will read it out.
Sure.
Mr. Sanjeev Kumar Panda, thanks for asking 3 questions. In fact, 2 questions. One is about, it's a good afternoon. What is the impact on HR, heat rate and boiler, TG, PERF with cyclic operation in unit up to 50 times in a day to meet process load demand change? Mr. Raghavan, could you understand the question?
No, I understood that probably the ramp up and ramp down of capacities during the day so many times to meet the process load demand. Definitely, obviously, it will have impact on the heat rate. because sudden load increase, load drop will have, it is not the optimum way to run the plant. He has mentioned 50 times a day, it's too high, but definitely it will have impact on the heat rate, it will have impact on the life of the components.
But
Of
50
course,
is
it
too high.
depends on, of course, it
50
depends
is
on what is the ramp up and ramp down. If it is too high, that will have a significant impact on the life of the component.
no, but this is no brainer. I mean, 50 times is very large number, and I don't think it is relevant for coal-fired power plants.
Yeah, I agree, because we will not do so many times in a day.
Yeah. Mr. Panda, I think, are you satisfied with the answer or no?
But only thing is, sir, 50 times, for example, if the unit is running at, say, 50 megawatt, it may go to 55, it will come down to 45. So it's a small variation, that's fine. It is the part and parcel of cogen plant, because obviously the captive or cogen plant should meet the process requirement, because process plant is the main one, and the power plant and the steam generating plant should meet the process load requirement. Such a small variation is okay, but what here we are talking about is in case of large variation, it will have an impact, definitely. And we talked about that in the presentation also, how the such variations are going to have impact, and it varies from the unit rating.
Sir, Sanjeev is writing, Sanjeev is running a captive power plant. Load changes by 20 to 25 megawatt in a 125 megawatt.
So it's roughly 15 to 20%, 15 to 20% variation. Yeah, obviously this will have impact.
Okay, all right. So this must be a CFBC boiler, right? Coming so down 125 megawatt to 20 megawatt in a PC fired. Is it?
Yeah, Mr. Verma, they are telling the reduction is 20 megawatts. So 125 to 100.
Reduction is 25. Okay.
Reduction by, yeah.
Yeah, his another question is, what is the impact on heat rate loss and performance in boiler and TG if the load is increased and reduced by 20? Same thing, I think.
Same thing, yes, 20 megawatt.
All right. So, Sanjeev, I think you got the answer from our expert from TCE. No, he says it's a PF boiler. Okay, all right.
Yeah, PF boiler also is a PF boiler. Though we presented some numbers for higher capacity units, 600 and 800, we can evaluate for 125 megawatt also. Of course, I think it's a reheat unit only, because generally we go for above 120 reheat boiler. So we can calculate and we can estimate that also, what would be the impact.
All right. There is a question from Mr. Sandeep. During flexible operation of supercritical units, is it recommended to ramp down to the extent of dry mode operation to wet mode operating mode changes? Are there any software solution to study flow path variation in heat rate?
First, I will answer the software. Obviously, some of the companies have having that solution, but though it is not implemented at a full scale in India, but in abroad, we have seen, we are also discussing with a few external partners who are having such software solutions to study the variations of heat rate during the flexible operation. But in India, it is not yet done on a large scale. Probably I would ask my colleague who is going to present on the digital thing to include this, which is going to in the afternoon session. He would be able to talk about that, what is available elsewhere, if not in India. Of course, he'll be able to describe how the heat rate variations can be captured or studied using these software solutions.
So your colleague is from TCS or from TCE only?
TCE.
Because TCS also has a lot of solutions, looks like.
Yeah, but I referred my colleague from TCE. We are discussing with a few partners, because we want to offer the solution to our customers along with the partners, so he can talk about that.
All right. So Shriyal, I think no more questions. So should I move to Mr. Bhartiya and Mr. Agrawal?
Yes, sure.
Mr. Agrawal and Mr. Bhartiya, I think you are very much there. Hello, Mr. Agrawal. How are you, sir?
Fine.
It's a pleasure and honor to share the dais with you. It's an opportunity. Mr. Bhartiya is there, so good to see both of you.
Good morning.
And a lot of learning. I have been learning a lot from you people while you were in NTPC and after that also. And seeing both of you is a pleasure in any event. You people have kept the torch of thermal power plant high and glowing. So wonderful and good to see you. So you have a presentation to make, Mr. Bhartiya and Mr. Agrawal?
We can switch over to the presentation.
All right, please go ahead, sir.
Who would be sharing the presentation so I could give you the access accordingly?
Yeah, please give it to me, Agrawal.
Sure. So I've just given you the access.
Okay.
You could just open your presentation first.
I'm doing that. I'm doing that. So I've opened the presentation.
Now you would require to come back to the Zoom screen and you would get a share screen option at the bottom of your screen.
Yeah, that's why I have done. Advanced sharing. This is one panelist can share at a time. Advanced sharing options.
No, sir. You just need to click on share screen and select the presentation. Okay. If it's open on your system, you will see the presentation.
It is open, but I don't know. You are not able to see, na?
No, sir.
How this? This is. नहीं वो तो कर दिया मैंने क्या ये फिर गड़बड़
Sir, can you just email us your presentation? We can share it from our end and you could do the presentation if that helps.
Yeah, I will do that, but it should not be a problem.
Yes, actually it shouldn't. If the presentation is open, you just click on share screen and you will view the thumbnail, a small picture of your presentation.
I have opened it. In fact, it is open in my PPT. But,
yes, but I'll not be able to view it till you don't share it through the share screen option on Zoom.
Share. So now can you see?
No, sir, you haven't started sharing screen yet. When you click on share screen and select the presentation, again, there will be a share button that you have to press. It should be at your bottom right.
Right, यही होगा ना?
ये तो नहीं आ रहा है। क्या है यार? बड़ा गड़बड़। सरप्राइज।
आपने अभी share screen पे click किया, sir?
हाँ।
So you will see some files, whatever is open on your system. उसमें से एक आपका PPT होगा.
नहीं मतलब PPT में सबसे बॉटम वाले में तो दिख रहा है, बट आपके वाले में या मैं मेल
राइट में बोल रहा है।
आप मेल कर दीजिए, मैं अपने यहाँ से शेयर कर देती हूँ.
मैं कर देता हूँ, ये पता नहीं किसका, मैं मेल कर रहा हूँ.
Yes, sir, surely. In the meanwhile, if you can just start introducing your topic and your company to the attendees, by then I'll receive your email and I'll share screen.
Just क्या नाम से था?
Environment.
ये तो गड़बड़ हो गया यार, ऐसा तो होना नहीं था.
बता दीजिए. It is sent to Sheetal Mishra.
This I have sent to Sheetal Mishra
Yes,
mail.
sir. We are together only. We'll just share the screen from here. Give us a minute.
Very surprising. ये मिला नहीं यहाँ पर.
इसमें तो कुछ नहीं.
शेयर स्क्रीन पे क्यों नहीं आया? अच्छा, डिसेबल्ड.
हाँ, वो तो कर दिया होगा.
वो नहीं समझा था मैंने. So, by the time you switch over, we can.
We have received the mail, sir. We are just starting, but you can just start with introducing what the presentation is going to be about.
Well, thank you for inviting us for this conference and on this improving the heat rate and for its optimization. We are going to share with the based on our experiences in NTPC, what are the type of initiatives taken and what type of efforts which has been made, in improving the heat rate of the power plants. And for that, what we feel that this is a good forum for coming out with the type of experiences. Next. So the presentation covers which myself and Mr. Pankaj Bhartiya will be covering is on energy efficiency overview, heat rate deviations, cause and effect, and a system approach for implementation, approach for auxiliary power consumption optimization, and improvement through O&M practices. And of course, there are some new technology interventions which are also beneficial, and finally summarizing on that. So next, please. So there's energy efficiency when we are going to improve is going to be a big driver for reducing greenhouse gases and CO2 emissions. That is, as we know that when you burn 1 ton of coal, it's almost like 1.2 tons, 1.25 tons of CO2 emissions, and there is a very high impact. At the same time, that is the improvement on this performance is going to be a big benefit to the utility in terms of the natural resources, in terms of the cost involved, and what are the other factors which will be affected during the operation of the plant. So it's almost a win-win situation for the in all respects, and we are going to conserve natural resources which are very much needed, because of keeping the future requirements. And we have to fix up the prioritization of the cost-effective solutions for the degradation in the thermal power plants or equipment performance. And for doing all this, if I want to find out the cost-effective solutions and I want to prioritize them, it's very much needed that there should be some systematic approach. There should be some sort of a menu in front of the utility at all the time, where he can identify what are the activities which he should initiate depending upon the funds available, depending upon the initiatives which management is going to take. And we can plan recovery losses also accordingly, because it's all it's a trade-off. What type of, as what Tata has mentioned, that the cost involved is also if I want to improve certain performance, there may be in cases, in some cases there will be high cost involvement. So it has to, it all depends upon the utility efforts. There may be certain low hanging fruits, but then there can be a situation when it will call for a high level of investments. Next slide. Well, as we all know that that PAT is also a initiative taken, and it's a unique scheme for transforming the voluntary deductions to the mandatory regimes, and it has created a atmosphere, competitive atmosphere, and as such, within the organization, there is a systematic approach which has come out. And as it has been mentioned in the beginning, there are certain softwares also which has been introduced, like Epsilon and all. Of course, there are many other those heat rate deviation programs which are available, but those things are definitely needed. And as far as this PAT is concerned, it has also bring out emphasis on the renovations and modernizations, the type of efforts which are required to be made. And it should not be just like, simple overhaul, but then there has to be some initiatives for modernization of the equipments and whatever opportunities are available. And PAT has also created a requirement for a continuous process for the improvement in efficiency. So it's a all improvement without having any goal post for the. There is no limit to this. And then efficiency and loading factors are also very important in terms of the loadings of the unit, or as what one of the question which has come up, if there are trippings and unit is not running in a very reliable manner, is going to have a direct impact on the performance. So all those things are also to be taken care, and reliability is the platform to sustain high efficiency. Next slide, please. Well, here, like what it has been indicated in Tata's also, this is a typical example for a 500 megawatt, a 10 kilocalorie impact on heat rate is going to be about 3.27 crores, and in terms of the coal, it's 7,700 tons. And as I explained about the impact on CO2, maybe you can multiply this coal with the 1.2, 1.25, and that is about 10,000 or so will be the emissions impact. So, but then there is a saying that what cannot be measured cannot be saved. So I think we have to make efforts to initially do the measurements and by some accurate means, so that the deviations can be identified, and we can take action, corrective actions on those things. It's something like in a medical field, if I ask somebody what is your blood pressure or what is your sugar level. I don't think he cannot tell that until unless he has gone through a process or he has done some got this thing measured. And so the values are what type of deviations are there, and are they have been are how confident they are about those measurements. Those are also very important, and I think it needs to have a very accurate measurements on that. Next slide, please. This is also summarizing, this giving a similar thing on 200 and 500 megawatt units, typical that is for 10 kilocalorie. The level of impact is a very, very high value, and the type of situation which is prevailing in the power sector with the renewables in the field, it's a very competitive scenario. And I don't think we can afford to lose this type of money in. As such, I have another view on this, that we talk about supercritical, ultra supercritical, and all that effort is to further improve the heat rate. Now, at the same time, we need to understand that after certain stage, even 1 kilocalorie improvement, when we talk about supercritical and ultra supercritical, implication design cost implications are going to be something of the order of 4 to 5 crore. That's something you lose just like that. If I am not trying to make efforts to maintain and to achieve those parameters. So it's all the more important that we keep focus on this and have proper measurements available. So that is what we wanted to emphasize through this these type of figures. Next slide, please. Well, here are the type of exercises which has been done in the past. There are certain figures which we find that typical deviations. You can see condenser having losses of the order of 15%, dry flue gas losses 22% because of many reasons. The air filters may not be in a good condition, or seal leakages and all, and HP, IP turbine. These are many places the turbine efficiency degradations goes unnoticed, and or the some methods which are adopted for measurements are not properly followed. So we sometimes not getting exact informations. And of course, there are many unaccountables, like it has high energy drains, insulations. The LP turbine efficiency is also a very big factor, which we are not able to take measurements because of the moisture content in the last stages of the blades of the turbine. So, and then of course there are, as what has been shown by Tata, is about the reheater display, and of course cooling tower. The cooling tower is also, I think, it's a very, very important area from the point of view that these are some areas which are very low hanging fruits. We can definitely improve the performance without making much of efforts, because these are all visible things at the cooling tower side. Next slide, please. Well, now I request Mr. Pankaj Bhartiya to take over for this heat rate deviation cause and effect. Mr. Pankaj Bhartiya, please.
Thank you, Mr. Agrawal, for setting up the context of our presentation. In this, as has been mentioned, that it is important, as has been mentioned in the opening session also and our previous speakers also, that it is very important to have, every effort made to ensure the best performing heat rates and the performance of the machines. So next, please. Yeah, just a second. Hmm. Uh, Yeah, the heat rate deviation system is important component of the heat rate improvement program. And in order to develop a deviation program, it depends on, the accuracy of the heat rate parameters which are affecting the heat rate deviation, and they need to be measured in a more accurate manner. And the heat rate deviation components enable us to focus on the areas of the heat rate losses and and to make the action plans in the priority areas. The difference between the expected heat rate and operating heat rate should be fully accountable. And we always, say, talk about the expected heat rate. The expected heat rate and the design heat rate, the difference is that design is what is prescribed, but the expected is keeping in view the operating context and all the, environmental and other things into consideration. So the more realistic way of, benchmarking your performances with reference to the expected heat rate. Next, please. Yeah, the high.
Murtaza, we are not able to hear you.
Just a minute. Just a minute. Yeah, so the high unaccounted component of the deviation can be due to the poor database as well. And improving the accuracy of your unit heat rate requires intensive efforts with reference to that. However, the accuracy of parameters affecting the heat rate can be improved at a nominal cost. I mean, we need not consider all the parameters that we are measuring, but we can consider the specific parameters which are important from the assessment point of view. So operation of unit at optimum parameters would be resulting in achieving the best form of unit heat rate. So that is what we are going to focus through various systems that we devise. So I am right now connected to DK Agrawal's laptop, and
Next slide.
okay.
Next slide. Next slide.
So
Next,
next,
please.
please. Next. So the list of parameters to be monitored and tracked for heat rate deviation has been standardized and identified for most of the cycles. And these parameters are monitored very accurately during the PG test and routine test. So those levels can be taken as the references, and accordingly our parameters can be tuned. Then upgradation of station instruments used for monitoring these parameters is very essential. There are not many like your main steam temperatures or main steam pressure or the vacuum or feed water temperature. So there are some, about 20 parameters which we need to take care of, wherein we need to put in high accuracy instruments and keep a track of them by monitoring the accuracy of and the calibration of these instruments periodically. This requirement has been confirmed based on the recent testing done at various stations that we have found, because this is the area where we need to look at while we make our heat rate improvement program. Next, please. Yeah, the maximum heat rate deviation could be on account of degradation of vacuum, as has been discussed earlier also by the speaker. And under the worst conditions, the back pressure would affect unit output as well. So the deviation on account of HPT, IPT, LPT efficiencies goes unnoticed due to the lack of feedback. Auxiliary power consumption has a trade-off, and however, second highest rank. So we need to, look at all these things. Next, please. The effect of critical parameters in terms of kilocalories is just tabulated on this, which has been very comprehensively given by our Tata friends also. So this is what, the key parameters which the operator needs to, always keep in mind, and this keeps him guiding on to that why he should be looking at these parameters and ensuring the optimal operation of optimal maintenance of these parameters. Next, please. Yeah, to ensure all this, we need to have a systems approach for implementation of our heat rate improvement program. And some of the approach guidance that we have discussed in these next slides. So we'll just talk on that. Next, please. We need to focus on the systems and procedures for good operation and maintenance practices. And some of the enablers which need to be institutionalized are the energy efficiency management system. We should have a well-defined, well-documented, and absorbed by the people who are operating this system, and they need to be, following this. Similarly, the reliability and maintenance management system is equally important, because you cannot achieve the performance, the optimal operation of your various systems without having the proper reliability and the maintenance of these systems. Now, the outage management and planning is also a very, very important aspect in ensuring a optimal regime. For that reason, during the outage management, what are the different steps that need to be taken care of to ensure from overhauling to overhauling the best operating, regime, and the best of the heat rate throughout that period. So we need to plan the things accordingly on that. The skill development and training, as was being discussed in the earlier by the our moderator for this session, that the people are very important. Yes, the out of the four pillars of people, the process and technology, tools, and people. So the people happens to be the most important aspect, and he is the driver of all these other pillars. So we need to develop him, we need to provide him essential trainings, and his skill has to be in line with the requirements of the day. Now, the documentation and guidelines and awareness programs, we need to have everything documented and the guidelines prepared, so that the people can always refer to their day-to-day operations whenever they need anything. And we need to make the people aware as to why they need to do certain things. Then there is a role of advanced tools, technologies, and practices and systems, and the simulation and modeling tools which are available today in a more convenient fashion So I think that is a very important thing, and periodically people should be referring to that and getting a refresher courses also on that. And then AI based optimization and diagnostic tools, which is also now available to us. And as was said, not only that we have to depend on some foreign based solutions to this. We have the Indian entrepreneurs also which are coming into this, and they are developing these systems and making them available for the Indian and power plants, so they can also be made use of. And the analytical tools for flexible operation, there are analytical tools for flexible operation also developed by various agencies, including the government. Like there recently there were some workshops organized in all the 4 regions of the country on this. The tool was also introduced, the templates for the flexible operation developed by EPRI and CII. And I have personally gone through that, and it's a very, very useful tool for the context of the day regarding the flexible operation. So similar things, are being done, which are available commercially or even by the government, so they can definitely be made use of in our day-to-day operation. Next, please. Yeah, the system approach, systems for sustained improvement in efficiency and reliability, the EEMS system as we call it. Now, the first is the accurate gap and assessment and analysis. So the measurement, as Mr. Agrawal was mentioning, what can be measured can only be, saved. So first is that we need to have an accurate measurement of the process. Then we need to develop the action plans to recover the gaps that we find out of this. And for action plan, we need to plan the implementation. And we also need to consider if there is something which can be done through R&M or retrofits because of the better technologies available today. So that also needs to be considered. And of course, we talked about that skill and awareness is the key to the whole program implementation and the success of the program. Next, please. Now, another concept that we would like to mention is that the grossly measuring the heat rate of the unit is just an indication of, yes, we need to do something, but it doesn't tell us exactly where we need to work upon. So for that purpose, we need to follow the subsystem approach. The approach is to introduce user-friendly systems, demonstration, finalization of procedures, guidelines, and dissemination to all. And for each subsystem, like air heater, mills, HP heater, boiler feed pump, or condenser, to the recover these losses. And also, we should always bear in our mind from the practical point of view that whatever is convenient will only be replicated. Okay. We cannot make very complicated systems so that it may be difficult for people to really follow. So we have to keep in mind while we are forming these systems and procedures that it is convenient for the operator to follow so that they can definitely be followed. Next, please. Then, as we mentioned, that optimization of the equipment performance is very essential to have a good heat rate. And optimization of the performance of the systems is possible through two means. One is the operation of the system, and other is the upkeep of the system, and in order upkeep and the reliability of the system. So in order to have the reliability of the system, we need to have some program in our maintenance management that ensures the contextual reliability and performance of the various systems and equipment. And in order to that, one of the systems that we followed and we have found it to be useful is reliability centered maintenance approach, which is nothing but the maintenance rationalization with reference to the current operating context. Now as far as the current operating context is also concerned, this also keeps changing. The units which were considered to be base load units at one time are under the cyclic operation because of the flexibility and other reasons. So we need to consider and tune our maintenance program uh, uh, in the current operating context. So the cycle of this reliability centered maintenance program is that first is we need to prioritize our systems where we need to where we are finding that the reliability is wanting or the performance is wanting. So those systems need to be identified and prioritized first, and then we need to the recommendations of the frequency and scope of, we need to analyze the various systems with reference to the failure modes that they are having, and for those failure modes we need to develop the strategies as to what needs to be done to contain them, and then what are the various preventive maintenance or predictive maintenance or overhauling, or as we said R&M, whatever needs to be done on that, that needs to be defined. I mean, the maintenance requirements need to be defined with a reference to the failure modes for not achieving the performance or the performance standards of that equipment. So that is what we need to do. Then comes the tracking of performance and maintenance. Now whatever tasks we have defined, we need to track them and ensure the efficacy of that, and also the performance of our equipment with reference to the standards we have specified. So that is need to be done. And then identification of the equipment of concern, as what we mentioned already on that, based on the high breakdown or new failures modes or repeat failures or high losses. So that needs to be continuously monitored and identified, and picking those identified equipment which, even after following a strategy, are still wanting some intervention, so they need to be taken care of. Now the revisit of the program, uh, I mean, we have done this, and then we can identify, based on this we need to revisit them and redefine our maintenance tasks and a strategy to contain those deviations. So the maintenance rationalization and sustaining functional performance of the equipment and system is what can be ensured through a program like RCM. So next, please. So now I would request Mr. D K Agrawal to take on the approach for auxiliary power optimization.
Yes, I think when we talk about the net heat rate, as the topic goes as per the conference title, I think auxiliary power consumption is having a very high implication, and we need to make justice towards this and identify the potential areas for its optimization or for reduction by adopting various technologies, so that there is a proper care taken about the for reduction of auxiliary power. Next slide, please. Well, there, as I told, energy saving, it can be in two ways. One is in terms of the energy conservation, that is like, reduction in the amount of energy consumed in process or systems, or by, so that is the, for example, you are adopting LEDs, or you are adopting unwanted auxiliaries to be stopped and all those type of things. And another area is efficiency. So energy and efficiency refers to the using less energy. Here it comes the basically about LEDs and all, or here it is about the for the optimization of the auxiliaries. So I think there are two aspects which are to be taken care when we are talking about the auxiliary power optimization. Next slide, please. These are some typical systems, elements of a in power plant, in a draft system, feed water system, cooling water system, cool handling, ash handling, compressed air, water treatment, lighting, and your many other areas, air conditioning and all. And these are the various systems which are deployed. If we look at the level of percentage involvement. Next slide, please. Next slide. So here is this, we can see in a 500 megawatt unit where the MDBFP is not there. Generally, we have TDBFPs. With that combination, draft power consumptions having involvement of 30% or of the order of 30%. Typically, and CW systems 23%, milling 10%, condensate pump power consumption 7%. So these are just some major areas where the auxiliary power consumption is involved, and we can definitely identify the possible improvement which are there. For example, we know that in the draft system nowadays, what has been talked about some time back is variable frequency drives. I think one of the first area which any plant would like to go for is the ID fan, and of course then there are many other such auxiliaries. Now improvement through O&M practices is monitoring of deviations of critical parameters and used for performance problems analysis. Now, as what Mr. Pankaj Bhartiya has explained about the parameters, critical parameters, so like, if we are tracking of the vacuum, main steam, hot seat temperatures, O2 oxygen at the in the furnace or at the air filter inlet, now there are certain 7-8 parameters which can be very closely monitored and tracked to optimize them, will make a big difference on this. And timely detection of problems like condenser vacuum, mill, air filter performance and deteriorations. See, as we know, air filter exit temperatures, even 5-degree higher exit temperatures are going to something like 5 kilocalorie, or the performance of the mills are going to directly impact on the your combustion. But at the same time, many places we have seen there should be a proper trade-off between the replacement of the rollers and auxiliary power consumption. So many aspects have to be seen from that point of view. Condenser vacuum, we have to also take care about the water quality and make sure that there are not, it's not creating too many deposits on the tubes. There are going to be opportunities for the cleaning during the overhauls, but then it has a direct impact, and as we discussed some time back, have very high implications in terms of heat rate. And combustion and soot blowing optimization is also sometimes people are religiously just following that key. Okay, at this frequency we have to carry out the soot blowing, but then we feel that for each individual power plant, for each unit, there should be a local study done and analyze that whether how frequently each tier needs to be operated, and see its implications. So it needs to be studied and decided, and that should be adopted as operation practice. Similarly, as I told regarding the chemical cleaning, chemical dosing, it's very, very important. And if we are not taking care of this properly, there are going to be algae deposits in the cooling tower. There are going to be, if the water is not of proper quality, then there are going to be hard deposits, which sometimes becomes difficult to remove in the condenser tubes. So I think better to avoid those type of situations, because you have a limited type of tools available to remove these hard deposits. So otherwise, ultimately, going to be solutions are going to be chemical cleaning and all, which is not a very healthy thing. And if it is to be done very frequently, stoppage of additional auxiliary equipments, and that also is very much to be taken care, particularly in coal handling plant or in the milling system. In milling systems also, when we are talking about the flexible operation, and but then we find many places people are not optimizing on the mills because of the certain requirements from the operation, or I think there needs to be trade-off. Otherwise, at a partial loading, the auxiliary power consumptions are going to be very, very high, which will be at the end of the year will becoming a difficult thing to justify. There is a strategic operation of efficient units at higher loading factors. So we can definitely identify based on the performance of the units. If I have been given an opportunity, which are the units I am going to run first, and after that, and of course, those things are very much needed. Use of opportunity cleaning of condenser and air heaters. Sometime I have seen that particularly in case of condenser, that it may be worthwhile to take a short shutdown and do this some cleaning of the condenser and come back, maybe just the top half of the condenser, because major deposits are on that. You will be very much benefited. You can definitely make an assessment. What is the DP across condensers and all, and then take those type of decision. But then it is worthwhile many times. Next slide, please. And improvement through this proper optimum coal blending is a challenge. Is also, I think we all experience that. Although many places people say that you're not getting a desired quality of coal, but I have seen some of the plants where they are meticulously keeping some heap of different calorific values, and blending. They are doing a simple blending, that is knowing this that this heap is of this calorific value and other heap of what calorific value, and what is the coal you are getting. So they are able to just analyze and see that what is the final average calorific, almost calculated figure, what is the calorific value which is getting fed to the furnace. I think that helps a lot. And regarding the this furnace slagging, fouling characteristic, blended coal, and those type of things definitely create problem. But then recently, one of the place we have experienced that after the overhaul of the unit, if the clean air flow test is conducted, then you are able to know whether there are uniform flow which is taking place in all the coal pipes. And in fact, to everybody's surprise, it was also found that one of the pipe which was of the mill, which was less used, there was one of the pipe which was found choked to quite good extent. And another type of analysis which has come out was that the information which was available at the operation desk in terms of the PA flow versus the actual flow which was going into the furnace, there was a big difference. And they were feeding much more amount of PA air, primary air, which because the desk was showing that you are feeding less. So I'm saying that there are, I think we need to continue follow those procedures which are there, and there are very good tools also available. So these things help a lot, in it, and the plant finally is going to be benefited in terms of the avoiding slagging in the furnace, because you were feeding much higher PF flow to the furnace. So these are some of the things, and this will be saving the auxiliary power also. Next slide, please. So energy audit and is also very much needed. I am sure many utilities must be doing this: insulation audit, auxiliary power audit, and for auxiliary power, we strongly recommend that energy efficiency management system should be put in place, because when we are talking about a partial loading and there is so much crisis in such a competitive scenario, this energy management system must be there to, and with that data, in fact, one more thing, that energy management system which is also integrated with DS, so that you are getting, for example, for mills, you are getting this 8 kilowatt per ton are you crushing, or 10 kilowatt per ton are you crushing, so that one can fix up the priority on the mills, and he can take a standby mill and take corrective actions. So similarly on the boiler feed pumps, and so I think energy management system with a integrated facility for the if not every auxiliary, let it be for the 11 kV and 6.6 kV ST motors case. That will be very helpful. And similarly, monitoring and optimization for the startup shutdown. I think there are some utilities where I have seen they have prepared the chart that if for a startup, what are the auxiliaries which will be needed. When you have come to the synchronized position, what are the auxiliaries which will be in service. And when you are going beyond certain load, what are those other auxiliaries which will be brought in? There should be a set procedure, set number, so that whichever shift the unit is coming, everybody is aware that this is the system, this is the procedure, and these are the auxiliaries to be running in startup and during synchronization. So next slide, please.
Mr. Agrawal, request you to just summarize the session a little faster now.
Now, things will not be, the efforts, whatever has been made, will not be complete until unless we are making equal efforts for the overall to be made meticulously planned. And all those spare parts, all those equipments which are tools and the facilities are available, and you have the proper records available, you have the developed action plan, which are the auxiliaries are going to matter a lot. Sometimes we have seen even there are cases where the overhauling is taken up, but you don't find the sufficient number of baskets are available for air heaters, or they have planned only condenser bullet cleaning, but then there are such a hard deposit that that will not be sufficient enough to take the corrective actions. You have to go for a chemical cleaning. So I think there has to be reasonable assessment about the problems, and the action plan is made accordingly. And one more thing, that if whenever we get some opportunity to upgrade particular equipment, I think we need to also use those type of opportunities, because again it is becoming such a competitive scenario that if I am not taking those type of initiatives, it's going to affect in the long run. Next slide, please. And as it has been mentioned and by in the presentation of Tata also, that there are certain new technologies which we have to keep on adopting. Of course, there are some of the simple things are the pump coatings, variable frequency drives. I have seen some of the plants which are of a very smaller size, even maybe less than 200 megawatt, but then they have gone for so many equipments wherever the VFD is needed, and they are getting a full benefit. Similarly, on the pump coatings, it's not just only CW pump or where we need to go for this pump coating. There are other equipment, ACW, your ash handling, and where the again they are getting benefited adopting those technologies. And energy efficient upgrades. There are some better profile impellers which are available for boiler feed pumps and all those things. So then there are cases where I've seen air preheater, people have increased the size of height of the baskets, or they have changed the profile of the baskets and benefited by that. CFD study is also, I think many people have adopted doing this in the draft systems, and many times you find that unequal flows are there, or even avoiding the recurring problem of and attending during overhauls, that is of the duct leakages, can be taken care by making CFD study and attending those things, and deflectors, diverters, and all those things can be installed. And of course, real-time tracking of efficiency, what we have talked about many times. But then I have a caution to this real-time tracking of the performance, that we have to be, the instrumentation has to be very, very accurate and very reliable. Because if the data is not of the quality data to the this real-time tracking system, we will be getting a wrong informations for taking the actions, corrective actions and all. So it has to be, the confidence level has to be built up of the people who are on operation desk or who are in the operation field. And of course, one of the system which we strongly recommend is the APR, that is your advanced pattern recognitions. Is found to be very, very useful tool for tracking the at a very incipient stage of the problem occurring anywhere. You are able to identify and take the corrective actions. So it is found to be a very good tool. And next slide, please. Next slide. Yeah, that is, this is just giving one example. There are cases where in some of the utilities, what they have, see, there are high level of slip losses in the boiler feed pumps, hydraulic coupling. So many places people have replaced these hydraulic coupling gears, and these slip losses have been reduced, and you can see in this table the type of savings which they are able to achieve. So I feel whichever type of particularly like up to 300 megawatt units and all, because 500 we have a TDVFP and all. But then it's a quite good, it's beneficial, and you can have a good saving. Next slide. This is another case where they have adopted superior quality of refractories, and it does not need the cooling water flowing over that, and by this they have reduced the consumption of water, and at the same time this is becoming a more maintenance free type of activity. So I think these are some of the, I'm just giving some examples only from this point of view, that yes, there are potentials for taking new initiatives, and we can continue to do that. Thank you. Next. So whatever we have talked about, there are issues that you need to have a top management support for efficiency improvement, because without that support, the opportunity to be created, the funds to be deployed, and all those type of things may not be possible. Awareness of efficiency impacts. We have to continuously monitor the performance and find out what are the losses. That is how I am able to project to the management that this is the type of loss which is there, and you have to convince them. Then skills, knowledge, and advanced tools with what we have talked about have to be there. And of course, the people have to be continuously in touch with the other utilities and have a exchange of informations. And a limited investment for efficiency restorations if the funds are not available, because many places I have seen there is a very high level of benefit which is there, particularly coming out with partial loading and all to adopt VFD, but they find it hands tight that they can't take up this initiative. I think it's a worth. There are some of the companies who are providing even such type of services on EMI basis, which is coming out to be much lesser than the type of benefit which will be there. So I am just, although I expect there will be support from the management, and systems and planning for efficiency monitoring, what Mr. Pankaj Bhartiya has shared, has to be in place. There has to be proper procedures documented. There has to be some reports available, and everything should be available on e-formats only. Then only these benefits can be availed of those type of information. And changing established utility practices is also a constraint. I know that it's not easy to change some practices which are adopted, but then there has to be an approach, and there has to be a continuous skill training programs and all. Without that, whatever we need to do in a change scenario will not be coming forward. Next. So this is just to summarize that whatever is the benefits are there through PAT. Efficiency can be achieved adopting better O&M practices. Operational excellence not enough to bring high degree of improvements. There has to be certain other type of efforts which we have shared just now. Maximize uses of opportunity for recovery of efficiency losses. Focus on overall effectiveness and sustenance of improvements. It's very much needed. It has to be a very planned manner. There are cases when we see people are not planning the efficient overhaul, like at least 12 months in advance, and taking those type of initiatives so that the desired spares and all other resources are available. Need to integrate new systems, technology, and practices. Efficiency and reliability improvement through R&M for old units, and of course reliability. And I also feel RCM is a very, very important tool nowadays, and for that necessary SAP and other facilities has to be properly integrated, and inputs are to be given to SAP. Without that, RCM will not be possible to move forward. Heat rate improvement is a journey. Without a goalpost, it has a continuous process for improvement. And partial loading, as it has been shared by Tata's, it's a very all type of efforts in terms of the auxiliary power, in terms of the heat rate, and in terms of, because there has to be initiatives taken at site, by doing some trials of cutting down the auxiliaries and see how you can make that a stable operation. So all those type of efforts have to be made. I think next, please. Thank you. Thank you. And,
thank you, sir. Thank you for the great presentation you made, Mr. Agrawal and Mr. Bhartiya. From both the presentation, one thing is clear that using the coal close to the design value.
Sir, your mic is off. I think your mic is off.
On. Shreyal, can you hear?
We are able to hear you, Mr. Verma.
Oh, wonderful. All right. So best O&M practices and RNM is the way to go to have the best plant life, lowest possible emission.
Hey, your voice is not. We are not able to hear you.
Sir, others are hearing me. I think you have some problem.
Mr. Agrawal, can you hear me?
Shreyal, do
Mr.
we have
Agrawal,
time
can you?
for the question answer or we close it?
Do you have any questions, Mr. Verma? Because right now I don't see any questions from the attendees. Mr. Verma, I'm unable to hear you now.
Can you hear me now?
Yes, I can hear you now.
Yeah. So
Mr. Agrawal, can you hear us?
Yeah.
Okay, perfect.
Agrawal,
Continue,
can
Mr.
you hear
Verma.
me?
Yeah, I can hear you.
All right,
Mr. Verma, we'll take one question from you and then let's conclude the session so that we move to the next panel.
No, my question is all rapid fire, only very quick.
Okay, go for it.
To TC and to our NTPC seniors, ex-NTPC seniors, two rapid fire questions. Any one of you can answer. Retrofit, renovation and modernization of subcritical unit are running supercritical unit at part load. Which one is your take?
Can you again repeat the question?
Yeah, my question is renovation and modernization of subcritical unit to make efficient and regulatory compliant are a supercritical unit at part load. Which is your take?
Well, see, one thing as far as supercritical is concerned, we are finding there are cases when you are running at a partial load and your parameters are coming down and you are not able to you are away, you are in fact away from the supercritical zone.
Sir, but give me answer in one. Retrofitted subcritical or supercritical at part load? Bhartiya sir? TC, colleagues from TC?
Yeah. It's part load because
you choose one of these. That's all.
Yeah. We will go with the part load operation of the supercritical unit, sir, because it will have still it will have some benefit.
Yeah, I mean, part load operation is not your option. It is something, a requirement which is mandated and you have to just follow. So the supercritical units or subcritical units, they have to follow that regime.
All right, very diplomatic answer. So my second question, very quick question again. There is a 600 megawatt turbine, and customer wants to get the retrofitting done. And the OEM is offering two options. One option is replacing a turbine-driven BSP with motor-driven BSP, increasing heat rate at a very high level. And second option is steam path retrofit, slightly lower heat rate. Which one is your take? Both the teams. Can I repeat? TC team?
Yeah, you can please repeat the question, sir.
My question is, there is a 600 megawatt turbine. Customer is looking for retrofit. and OEM is offering two options. Option number one, replace turbine-driven BFP with motor-driven BFP and achieve higher heat rate. Second option is steam path retrofit, slightly lower heat rate.
No, we will certainly first try with flow path improvement, and we will see how we can get benefited in terms of the turbine efficiency, sir.
All right. So you will go with the turbine-driven BFP retaining and steam path retrofit, right?
Yeah.
All right. Mr. Agrawal, Mr. Bhartiya, you want to say something, or we conclude?
I think I am with the TC on their and what they have said will be the.
Thank you so much for your participation, great presentation, and great answers. Thank you so much. Shriyal, over to you.
Thank you, Mr. Verma. Thank you all our speakers of this session. I think this was highly informative, and we even surpassed our time, but I see the other speakers were also very interested and keenly focusing and listening at all the insights being shared. So thank you so much, Mr. Raghavan, Mr. Nayak, Mr. Bhartiya, and Mr. Agrawal for joining us for this session.